Today we will be seeing the concept of SQL joins. So, in any SQL database or relational database, we have something called as relational entity. Relational entity is nothing but a table. For example, student table, employee table, department table, etc. And all of these tables they form the basic building blocks of any SQL database. Now, in enterprise databases, rarely we see a single table in existence. All of the times, it is a very complicated schema that we have of interrelated tables. So, all of these interrelations of the table, they are mentioned by cardinality constraints on the relationship between the columns within such schemas. The constraints are one to many, and many to one. Their whole purpose is to ensure the data integrity in the database. Now, these cardinality constraints are enforced by the use of primary key and foreign key. Joins are used to retrieve the data from related tables in a single query, and they use these primary keys and foreign keys for the same. So, let us see what are the common types of joins. So, basically, there are three types of joins: the inner join, outer join, and the cross join. Now, outer join again is of the variety inclusive or exclusive. Each of the inclusive is again divided into left, right, and full, and each of the exclusive is correspondingly divided into left exclusive, right exclusive, and full outer exclusive, followed by the cross join. So, we will see all of them. For that, we will have to create a database. Let us create it. Okay. So we will be creating two tables, the department table and the employee table. So let us create the department table and the employee table, and let us see. Okay. So department table is created with the department ID as primary key, followed by department name, location, and department manager. Each of the department is having a department manager, and the employee table is having employee ID, employee name, email, department ID, and one foreign key is defined. So employee ID is the primary key, and here the department column is mapped to the department ID present in the department table. So this is the constraint that we are going to work with. So if we want to depict this in the form of ER diagram, we will have this kind of a diagram created. As we see, we have one employee table and one department table. An employee table is having EMP ID, EMP name, email, and department, where EMP ID is mentioned as a primary key. Similarly, in department table, we have DEPT ID as a primary key, but along with that, we have this DEPT ID mapped to the department of the employee table. So this is how we depict the in the form of ER diagram both of these tables. Now we see the connector over here mentions a circle on the right side and circle on left side. The circle is used to denote any null values that can be present. So in our department table, the mapping column, that is the DPT manager, can be null, and in the employee table we have DPT which can be null. So in this way we are depicting, and the multiple lines over here, the four lines over here, they depict the many relationship. And here there is a one that is present out here which specifies a one relationship. So it is a many to one relationship. Many employees can be present in one department. So now that we have seen about the tables, let us start with filling the table with values. First, we have the department table which will have four values, followed by the employee table which will again have four values. And now let us see what we have. In the employee table, we have four records where the last record is having a null in the mapping column. That is, the department has not been assigned for this fourth employee. Remaining all the employees have a valid department mapped against them. Then seeing the next table, that is department table, we have four departments where the last department has yet no department manager been assigned, and the first three are having a valid department manager assigned to them. So this is what we are going to begin with to demonstrate our joins. So as we have seen, the inner join is going to be our first join, and the syntax for the same is select star from employee, inner join the department. So employee is had at the left side of inner join, department is at the right side of the join, and they have one joining table, joining column, e dot department equal to d dot department. So by this, all the records that we see out here, this is what gets returned by this inner join. So all the records which are having a valid column value in the mapping column are returned. So we have e dot department is equal to d dot department id. So in the Venn diagram, they are depicted like this. Suppose that this is the employee table is depicted by this circle and the department table is depicted by this circle. So all of the employee records are lying inside of this circle and all of the department records are lying inside of this circle. And what is present in this part is where we have the employee being mapped to valid department and the department being having a employee manager assigned to it. So these are the records that lie over here and these are returned in the inner join. So inner join is depicted by this diagram. Going ahead, we have the right outer join exclusive. So now in right outer join, what happens is that all of the records of the right table. So now department is lying on the right side. So department table will be having all of the records included in the output result set. And what comes from the employee table is only those records which satisfy this. E dot department is equal to D dot department ID. So this, as we seen, there is a one null value present in the employee table. That record is not returned. Instead, the table, the record which is having no mapping is returned as a null. By default, null is getting populated in the values where there is no mapping found because department ID 4 is not mapped to any employee over here. So this becomes our right outer join exclusive. And then we see the left outer join. But before that, let us see what is the Venn diagram for the same. So in this, what we see is the right outer join where we have the uh, all the values of the department table. That means over here and where E dot DEPT is equal to D dot DEPT is again over here where we see a mapping. This is the central part where we see all the mappings that are present and outside of the central part are the records which do not have the mapping. So that is how we depict the right outer join exclusive. Now we see what is the left outer join exclusive. It is the same concept. Only thing is that the left table is getting returned completely and from the right table only those records are returned which have a valid mapping. So our Venn diagram for the same becomes like this where all of the records of left are returned and from the right side only and only those records which have a mapping they get included into the return final result set. Then we see what is the okay. Let us complete with the full outer join as well. So when we say inclusive, sorry, we saw till now both of the join queries were inclusive. Right outer join inclusive, left outer join inclusive. We have seen these two. Now going ahead, we see the full outer join inclusive. For that, the query is such, but in MySQL, this query doesn't run. So in MySQL, we have to change it using the union all. So full outer join is exactly opposite to the inner join. In inner join, we only return the records which have a mapping present. But in full outer join, we present all of the records from the left and all of the records from the right, and therefore this becomes our Venn diagram. This is the full outer join inclusive that we have right now used using the union all. And now we will see the exclusive. So for the exclusive, we have this right outer join exclusive where we have again the Till here we have exactly same as the right outer join, but we have to add a where clause now over here where e dot dept is null. So where the left table is going to be having the mapping null is returned. So when we say the Venn diagram for this, let us first clear this all, and we have to see the right outer join. So for right outer join, so definitely we need this. And what about the central part? That is being removed because we are saying it as a exclusive, right outer join exclusive. So e dot dptid is null. So when we say e dot dptid is null, that means we have this department is going to be null. Department is at the right side. So we have the e dot dpt mapped into null. So when we say e dot dpt is null, we have over here the null value, and that gets returned as a right outer join exclusive. And exactly opposite is the left outer join, where we see the record being displayed as from the left table, but the mapping column is null. It should be null over here. So that is depicted by this. And when we say exclusive full outer join, we have the same query again, but without the union all, we use only the union and we add this null over here. So the mapping columns are null in both of the scenarios. So what happens is we get these records returned into the final results because these areas now contain the records which do not have any mapping in the opposite table. So this is how we will run this query. So this is the union query, that means the full outer join exclusive query, where we see the DEPT over here is null and the department manager over here is null. And that is how we have these last join. We have come to the last join, that is the cross join. Cross join is nothing but a Cartesian product. That means each of the records in department table is mapped to each of the records in employee table. So we have this 101 department, sorry, the department 1 mapped to all of the employees, followed by the department 2 is mapped to all of the employees, and likewise. Even the null value that is present in the department manager, that record also gets mapped to each of the employees, and we get 16 number of rows returned. So this was all about the SQL joins and the types of SQL joins that we typically use.